Students, today we are going to discuss about the third term mode, that is the boundary value analysis. Okay, as the problem states, we will be basically doing the same problem that we have discussed in the term mode number 2, that is the triangle problem. There we use the decision table, and here we will be using the boundary value analysis, and we will just identify whether the triangle is isosceles, uh, equilateral, or scalene. Okay. In the boundary value analysis, we actually consider a range of values that a variable may take. See, if function f implemented as a program where the input variable x and x2 will have some possibly unstated boundaries, like the shown here. That is the boundary for x1, suppose between a and b. Similarly, boundary for x2 is between c and d. Okay, and then anything that goes beyond this boundary is considered to be an error in the program. Okay, and it is basically on the assumption that most of the error that occurs in the boundary areas of the variable, the values that variable take. Okay, so input range is basically checked for the boundary values which are near to the boundaries. Okay, so we have three: one which is less than the initial value of the boundary. Suppose here it is the a is the lower limit, so below a is the one boundary, one value. Similarly, x1 is in the range of a and b is the actual value, the correct values which the x1 should take, and another boundary is just above the b. So if these three values are checked, um, basically five values here, one which is immediately less than this one, little greater than this one, the boundary area, one which is the genuinely in the range, okay, and similarly the next boundary. So when we check these boundary conditions, we can identify the most of the error that may have occurred in the program. That is the identifying the surroundings or near values of the boundary. So now coming back to the triangle problem, we have these are the requirements which are there for this triangle problem. The requirement R1 is the system should accept three positive numbers A, B, C. Okay, as we have seen in the earlier problem also, that is the term of 2, the three sides of the triangle. Requirement R2 is based on the input should determine if the triangle can be formed or not. That is, whether the triangle can be formed or not, that is the input should determine. R3 is to identify whether the if the triangle can be formed, then it is whether it is equilateral or isosceles or scalene. Okay, and here as we are limiting the boundary between 0 and 10, that is the upper limit, the size of any side of the triangle is 10. Okay, so here is the algorithm. As you can see, three values are taken as the small case a, b and c. Here is a, b and c, and then we check for whether the triangle can be formed using this condition. If any of this condition is false, the triangle cannot be formed. And then we check for whether the triangle is equilateral by checking the equality condition between A and B and C. If none of the sides are equal to one another, it is a scalene one. Otherwise, it is an isosceles triangle. So testing is done using the boundary value analysis. The technique uses boundary value analysis. The boundary is in the range of 0 and 10. So anything near to the 0, below the 0 is another boundary, greater than 10 is another boundary, and in between 0 and 10 is another boundary, another class, which is the boundary class. Test cases are formed by using by forming the equivalent classes. So equivalence classes for A, the boundary A, the side of the triangle A, is we can say that U1 is one equivalent class which is less than 1. Okay. Another is which is between this equal to 1 and 10 in the range, that means in the range, and another is one which is beyond 10, greater than 10. Okay, so this forms the three equivalence classes here. Similarly, equivalence classes for B are same in that way, because the range we are keeping is the same. Equivalence class C is also between 1 and 3 equivalent classes that you get. So So using these equivalence classes, we can derive the test cases using the boundary value analysis. Now here comes the test cases. So you can see the if side any of the inputs are missing, then it's not a triangle. Expected output is not a triangle. So actual output is also not a triangle. Then we have the output when we execute the test cases, we get the output success. Similarly, if any value is negative, then also it's not a triangle. Both this expected output and the actual output is matches, then we say the test case is success. Okay. Similarly, for the isosceles triangle, we have to check for any equality between any two sides. Okay. Then it's an isosceles triangle. When there is one side is not equal, but the two sides are equal, then it's an isosceles triangle. If all sides are not equal, then it's a scaling. Okay. And this is the whether the triangle can be formed or not. Is this is the condition that we checked in the earlier part of the TermWork3 also, the same way it has to be checked here, that is 3 plus 2 is less than 7, right? So a triangle cannot be formed because this condition becomes false, right? The A is not less than B plus C, A is greater than B plus C, so that this condition is false and therefore the triangle cannot be formed. Same Same condition here also. This condition is false, so triangle cannot be formed. This condition is false, so triangle cannot be formed. All sides are equal, equilateral, and these are the additional three which were not there in the earlier term. That is the when the range goes beyond the boundary value, then we consider it's not a triangle. Okay, so it is because we are not considering we are the range has to be between the 1 and 10. So here 12 is greater than is out of range one side, so not a triangle. Similarly here the B side 12 is not a triangle, it's out of range. And here all the values of the three sides are out of range, so not a triangle. Okay, so this is what the how the boundary value testing should be done. Test cases should be checked. We'll be using the same eclipse.exe for executing the test cases. So we'll now click on the eclipse.exe. So and then we'll have the programs executed there to check the correct execution, that is to verify the program using the test cases. Now here we enter the Eclipse has we have run the Eclipse ID. So now you have to click the create new Java project. Okay. So we are going for creating a new Java project. Say the project name that we put here is the TermWork3. Okay, TermWork3 we have put. Now click on next. We have this source base created here. Okay, so we have this being created. So finish. So we see the TermWork3 here. This is the folder for TermWork3. Uh, now we see the TermWork3 here. This project got created. Okay, so this is the package that we get here. Okay, source package. So new package. We are creating a new package here, and let us give the name P1 in a similar way we did earlier. Okay, finish. Click on finish. we get the package here. Okay, uh, within the package we need to add the class. Okay, we'll add the class, and we have to give the class name same as the file name. Okay, so we are putting here. So here we have created uh, the program for the main triangle, that is the Java code for the main triangle program, that is triangle the Java. And you can see this one, we have created the code for the main function here within the class triangle. And there is the another function that we have created, that is the triangle type, to identify whether the triangle is equilateral, isosceles, or scalene, and that condition is being checked here. The first condition that is being checked is that the triangles should be, the input condition should be such that the triangle should be allowed to, that is, it is possible to create the triangle. So for that you have to check these conditions, these three conditions here, and then you check the conditions here, and then you check for the upper range of the values here, that is, it should be within the 10. Okay, and then if this condition is satisfied, the boundary value condition is satisfied, then we can have the condition check for A, B, and C. If the three sides are equal, it's equilateral. If none of the sides are equal, it's scalene. If any two sides are equal, it's the isosceles. This depends on whether the condition is met or not. Okay. So this is the main program. Now we are going to create the JUnit test cases for this, to check whether the program is taking the correct values or not. Okay, whether the to check the test cases, we will execute the test cases. So here, selecting this triangle program, triangle.java, go there to this particular icon here, with on the leftmost top corner, click here, and you find the JUnit test case. So click on the JUnit test case, you get this particular uh, pop-up window, where the name is the triangle test. Okay, you need to select the middle one. In the earlier TermWork, actually there was a mistake, and please rectify it. We need to select the middle one. Okay, so once you select the middle one, and this name is the same name that we have for the JUnit test case program. Okay, now after this, click on finish. Okay, it is a, let it be like this. Okay, that is the perform the following action, and we have a template for the JUnit test case open. Okay, now let's create the test cases here. Now in the JUnit, we have created these test cases, three test cases you can see here. That is the one which is checking for the equilateral triangle, another which is checking for the scalene, another which is checking for the isosceles. Okay, it's just similar to the way we have done earlier. Okay, mainly only difference is that here we are taking a boundary value, that it should be within the range of 10. Okay, anything beyond 10 will given uh, will not considered to be the triangle here. Okay, that is because the range we are taking within a particular range, it has to take. That is the equivalence class that we have created. Okay, so initially we are taking all the values within the class values only, to check whether the triangles are in the format or not. Okay, that is the equilateral, scalene, or the isosceles or not. So once we have done with it, now we have these three test cases defined initially for the uh, checking of the equilateral, isosceles, and the scalene. And as you can see, all the values within the range only. Okay, we'll gradually check whether it goes out of the range or not. So to run this program, here is the triangle test.java. You need to select this one, and you need to right click it. Okay, you need to right click this one, and then run as. Okay, run as the JUnit test. Click here. and what you get is the output as expected, all the values giving the correct result here. Okay, that is the scaling is correct. You can see the right thing here. Test isosceles is correct. Test equilateral is correct. Okay. Now if you change any values here, it's going to give a wrong result. So if you just put the value, suppose in the equilateral, if I am going to put suppose the 6. So it's not a equilateral triangle if we put a 6 here. Okay. So rerun this code. To rerun you can click here. Okay. So rerun it, click OK, and you see the equilateral has failed. You see the cross here, and these are the corrections. Okay. Similarly, now if we change the value, this 5 here, to suppose 11, because we are taking the range to be the range of values to be 1 to 10. So we are putting something beyond range to check the equivalence classes here. Okay. Say this value is also 11, and this value is also 11. Okay. Now change all these values to 11, 11, 11. It should be an equilateral triangle, right? Now rerun this code. To rerun this one, so let us rerun it, and we get, see, though it is equilateral condition is correct, since it is violating the boundary value. Okay, so we get an error here. Equilateral triangle, it is the cross and the rest two are correct sign. Okay, similarly for the isosceles also, uh, say here. Okay, let us make it 14, 12, 13. Okay, and let us run this code again. Okay, by save it, and then rerun the code. Okay, what we get here, you see, the scaling part also failed. You get a cross here. Only isosceles is now correct because this has violated the boundary condition. Okay, this is what the boundary value analysis test cases can be checked here this way. So this is the way to run the test cases. Okay, so you make it more general, this program, by including the output to storing the output properly. Okay, do little bit of analysis on this program and try to make the code, that is the output, should be this, the output display proper. Okay, that is uh, the output to be shown with a pop-up that this is not possible, or this is um, the error occurs in the testing, that is the test case fails or test case success. Because in both cases, you can give the output only as the test case success or test case fail. That's enough. Okay, but that should come in a pop-up. So do this little bit extension and submit the programs.